Welcome to the Explainer. Today we're going to break down one of the oldest and, honestly, most important building materials humanity has ever used. It's this amazing story of chemical transformation, a process that has, and I mean this literally, shaped our world for thousands of years.
So let's just jump right in with a bit of a riddle. What building material starts out as just a simple rock, goes through this intense trial by fire and water, and then, get this, actually gets stronger over time by pulling carbon dioxide right out of the air? Well, you guessed it, the answer is lime.
All right, so where does this whole incredible story begin? Well, it all starts with the Earth itself, with a very humble and really common type of stone. And that stone is limestone. You know, whether we're talking about the mortar in ancient Roman aqueducts or the plaster on a historic wall, limestone is the one and only raw ingredient. It's the absolute foundation for every single lime product out there. So what exactly is limestone? Well, chemically speaking, it's calcium carbonate. You'll see it written as CaCO3. But the coolest part is how it's made. It's a sedimentary rock that formed over millions and millions of years from the compressed skeletons and shells of ancient sea creatures. So in a very real way, when we build with lime, we're actually building with the remnants of ancient life. Kind of wild, right? But here's the thing. You can't just pick up a chunk of limestone and start building with it. To unlock its potential as this amazing binder, you have to completely change its chemical makeup. And that requires a pretty dramatic and fiery transformation. And this first huge step is called calcination. The whole point here is pretty simple, but it's also pretty extreme. You use incredibly intense heat to literally break the chemical bonds inside the rock and drive out the carbon dioxide that's locked away inside it. Okay, let's walk through that. You start with your limestone, your CaCO3. Then you heat it up in a kiln to about 900 degrees Celsius. That's over 1600 degrees Fahrenheit. This crazy heat kicks off a chemical reaction that forces the stone to release a molecule of CO2 gas. And what's left behind is a brand new substance, CaO, which we call quicklime. Now this quicklime, or calcium oxide, is fascinating stuff. It's super lightweight, it's porous, and it's highly caustic, meaning it's dangerous to handle. But the most important thing to know about it is that it's chemically unstable. It is desperately looking to react with something else, which, as you'll see, makes it perfect for the next step. So, we've used fire to create this unstable, really reactive powder. Now what do? Well, to make it safe, to make it stable, and to make it something you can actually use in construction, we have to bring in another powerful element, water. This next stage is called slaking, or hydration. And believe me, this isn't just like mixing up some mud. This is a powerful exothermic reaction. When you add water to quicklime, it literally boils, it hisses, and it lets off this huge amount of heat and steam. It is a seriously dramatic transformation to watch. So here's what's happening chemically. You take your unstable quicklime, the CaO. You carefully add water, H2O. Those two molecules combine in that really violent reaction we just talked about, and what you get at the end is a totally new, stable compound, calcium hydroxide, or CaOH2. And this is the magic ingredient right here. Hydrated lime, also called slaked lime, is that fine, fluffy, stable white powder that builders have been using for centuries. This is the stuff that gets mixed with sand and water to create mortars and plasters. The journey from a simple rock to a usable building powder is now complete. But wait, the story doesn't quite end there, because it turns out not all lime is the same. The final properties of the lime you make depend completely on the purity of the limestone you started with, way back at the beginning of the process. So this is the crucial point. Some limestone is almost pure calcium carbonate, but a lot of it has other minerals mixed in, especially clay. And the presence of these so-called impurities totally changes how the final lime is going to behave. And this really gives us two main families of lime. On one hand, you've got fat lime, which is made from really pure limestone. It's soft, it's super workable, and it hardens slowly just by absorbing CO2 from the atmosphere. But if that limestone has clay in it, you get something called hydraulic lime. And those clay impurities give it this incredible ability to set with water, almost like modern cement. This makes it way stronger and perfect for building in damp places, or even completely underwater. Now, to get a little more technical for a second, these differences are actually formalized in a classification system. Class A is your strongest hydraulic lime, the stuff that sets really fast, and Class C is your pure non-hydraulic fat lime.
The other classes are just for different kinds of impurities, like magnesium. The whole point of this system is to help builders pick the exact right kind of lime for whatever they're building.
So let's think about this. We started with a simple sedimentary rock, we put it through fire and water, and we ended up with this whole family of incredibly versatile building materials. It's a legacy that has really, truly shaped our civilization.
When you boil it all down, the reason we go through this whole complex process really comes down to one simple fact. Lime has amazing binding properties. It's basically the glue that holds sand and stones together, creating these incredibly durable structures that can last for centuries.
Let's just recap that incredible elemental journey one last time. It all starts with rock, the limestone. It's transformed by fire into quicklime. It's then tamed by water to become hydrated lime. And finally, it's handed over to the builder to be used as mortar and plaster. Rock, fire, water, builder. It's just such an elegant and powerful cycle.
And that just leaves us with one final thought. Remember how lime hardens by literally pulling CO2 out of the air? And it's often a local natural material. You know, in our modern world that's so focused on sustainable building, is it possible that the future of construction might end up looking a little bit more like its ancient past? Definitely something to think about. Thanks for joining us for this explainer.